All right, so I want to briefly recap what we just did in the last video. So we talked about homogeneous linear systems where we set AX equal to 0, and we know there's always going to be a solution, the trivial solution. However, in this example, when we were finding all of the homogeneous solutions for this matrix, we actually found infinitely many solutions. So more than just the 0 vector was the answer. So let's put a little note here. If there are free variables, that means there are non-trivial solutions. Which means we're going to have more solutions than just the 0 vector. So this is actually a really important note for the future of our course. Okay, so back to this problem that we were working on. We found that we were able to write every single solution to our system as x3 times this vector. Well, this looks just like a linear combination, right? A scalar times a vector. So that means every solution can be written as a linear combination of this vector, which means every solution is going to be in the span of this vector. So let's write that down. All solutions are in the span of -1, -1, 1. Or as I've called it, V, the span of the vector V, which is just -1, -1, 1. All right, so what does that even mean? What does that even look like on a graph? How can we write this solution set? Okay, so everything is going to be in the span of this, so everything is going to be a linear combination of this. So what I'm going to do is take this vector V, and I can write it as a point. -1, -1, 1. So I'm actually going to plot out the solution set. All right, so let's say this is I have to do 3D, which I'm sorry, I'm not great at 3D. All right, so here is x1, the axis, and this is positive, this is negative. All right, and this is x2, positive side, negative side. So I'm labeling it where the positive is. And then through the middle, we got x3, positive side, negative side. All right, so what I'm going to do is I'm going to take our vector v, write it as a point here. So I want to go -1 for x1, -2, sorry, -1 for x, so maybe -1, -1, but then +1. So where do they meet? Maybe somewhere here. Who knows? Maybe I'll like make a little arrow here, a little box that tells me they meet here. So everything that goes through that point is going to be in the span. All right, so if this was my V, if I continue the line in all directions, that is the span of V. So everything on that line is going to be solution to our homogeneous system. Okay, now let's look at the other type of solution set that we have. Okay, so the next type is the non-homogeneous linear system. And you may also hear it called inhomogeneous. I think that's what your book uses. Same thing. All right, so this time we're not going to set it equal to 0. So AX equals B, where B is not the 0 vector. That is our non-homogeneous system. Okay. So when we look at an example, let's try to find all solutions for a non-homogeneous system. So find all solutions, if any. Remember, we're not guaranteed a solution if it's not homogeneous, of AX equals B. All right, so A is going to be a 3 by 3 matrix. I'm going to go 2, 1, negative 1 down the columns. Negative 3, 1, 3. Negative 1, 2, 2. All right, so this is the same example we had before. The same matrix, but this time we're going to set it equal to some B, and our B is going to be the vector 1, 3, 1. Okay. So we will set up an augmented matrix. And then we're going to row reduce it into RREF. And so we should get the same setup on the left side as we did last time. But this time it's going to equal 2, 1, 0. Okay. All right, so now we can write our general solution. Okay, so this time we got a little more going on. So x1 we got 2 minus x3. X2 we got 1 minus x3. And then x3 is free. Okay. All right, so then we can actually write our solution in parametric vector form. And so remember, the easiest way to get started with that is to write our solution as is as a vector. So our solution is going to be x. And writing it as is as a vector in the x1 spot, I'm going to do 2 minus x3, 1 minus x3, and then x3 because everything is going to depend on the x3. All right, so this time when I'm factoring out, I'm just doing the constant pieces, and then I'm doing the pieces that are multiplied by the x3. So first, let's just take out the constant pieces. 2, 1, 0. And then we're left with negative x3, negative x3, x3. And then finally, I'm going to factor out the x3. Okay. All right, and so we'll pause here and take a look at the form that we get, see if anything looks familiar, and we'll talk about it in the next video.